Hi everyone, good evening, and today we will proceed to our next topic of discussion on the chapter of Newton's laws of motion. I hope you all have understood the previous lecture or the topics that you are studying. Now let's move on to the next topic. We have already studied the second law of motion. It stated, I am directly writing the mathematical expression of it. F external equals dp by dt. So from this expression, we have to read some underlying statements that it is trying to convey to us. The one is, if dt is given as some function of t, or t is given as some function of time, then f external will be the differentiation of, the slope of the pt curve. So this is just the interpretation that the expression is telling us. Now, second point is what? The area under the curve of area under the curve of ft will give us impulse or dp. That means delta p. If the measurable quantity is significant, or the difference is significant, sorry, it will be the difference. Now we have come to know about a new term, impulse. What is it? Though we all are so good in English, or means, what do you mean by or? Or means same. Okay, kind of that. That means impulse, as I have written, impulse or delta p. That means impulse is nothing but delta p. Okay. So what do you mean by impulse? It is the difference in momentum. That means I equals P final by minus P initial. This is the impulse. Now, if we try to write this in the form of an expression, then it will become F dt equals dp. This is lower limit is initial or final, and upper limit is final, and it is the integration. So it will become Pf minus Pi equal to F dt. And what is this? This is impulse. Impulse equals Pf minus Pi. Also, it equals F dt. Integration. Sorry, I missed the integration. This is the impulse momentum theorem. Okay, this is the this is the expression of the impulse momentum theorem. If we plot this in the graph of ft, let's say this is the curve. If these are the points, and we have to specify momentum in between these 2 points, then the area under this curve and between these 2 points will give us the momentum. Difference in momentum, and that means delta p. That means impulse. I hope it is clear to you. And if I want to draw this in curve, then this will be t by t. This will be the curve, and the slope, that means dp by dt will give us the f external. Okay, if I miss the sign of vector or the arrow, please give it by yourself. I sometimes forget to give it. So this is all about impulse and impulse momentum theorem. Now take out your pen and paper and try to solve the question. Pause the video and solve the question. So I hope you have already solved it. Now let's see what it has asked. A variable force acting on a particle of mass n from t equals 0 to t equals t naught. The ft plot is given. This is the ft plot. Particle is initially at rest. The velocity obtained by the particle is. That means the velocity obtained by the particle in this position. What do we know? From ft plot, we can find out del p. That means impulse. And what do we need to find? We need to find the v final. Okay, and the graph is given. Also, in the graph, it is stated that it is a semicircle. So, from the impulse momentum theorem, what we have got? That the area under the curve of a ft curve will give us the impulse or del p. That means the area covered by this semicircular curve will give us the del p, and we need to find the area. So we need v final. What do you mean by del p? Del p means mv final minus mv initial, or if we take m common, vf minus vi. It is already given that particle is initially at rest. That means vi is 0. That means del p directly equals impulse, that is mvf. We need to find vf, and we can find impulse from the curve. So if we want to find the area of the semicircle, then so wherever we can find the I from the area under the curve. So we know that area of a circle is pi r square. We also know that circle has been derived from ellipse, or we can write it as ellipse given by a into b, major axis and minor axis. In case of circle, both the axes are equal. That's why it becomes a into a, that means a square. We replace the a with r. This is the concept. Now, area of ellipse is this. So, in this case, the one of the axis is f naught and other axis is t naught. So, the area of the semicircle will become pi into f naught t naught by 2, because it is half. The other half portion is not there. So, this is our required area. Okay, so this is our required area. Now, pi r square. Pi r square by. So this is the area. Now, okay, sorry. I have done a mistake here. If the major axis, I mean, if A is f naught, then this is f naught. F naught. It is fine. But I have taken B as T naught. So the T naught is the whole part. I mean, this will come as the diameter, but we need the radius. So this will become T naught by 2. We need to put T naught by 2 there. Now it becomes f naught T naught by 4. This is the area of semicircle. Okay. Now put the area, equate the area with the NVS. We will get pi f naught t naught by 4m. Directly I am writing PS. This is your answer. The whole portion is the T naught. We only need the radius part. That means it will become T naught by 2. As already it has been stated that it is a semicircle. Okay, that's why I have taken T naught by 2, and after equating for a semicircle, we will get pi f naught T naught by 4. And the answer comes as pi f naught T naught by 4m. So this is your answer. I hope you have understood it. Let's meet in the next video.